We are going to look at this and make this new video about the 9 elements that we need to model using the bone graft technology. So in the chart that you see in here, you can see these 9 elements. We need two efforts, source and an effort of flow, which are the two sources. Let's say we need two connections. One connection that we're gonna call the zero junction and the one junction. So two connections. And then we have 5 other elements. So right there was almost half of what we need. And very simply, we need one element that stores kinetic energy. We know what we call the I element. Then one we need that stores potential energy, which we call the C element. One that dissipates energy, which we call the R element. And then we have these two elements that transform energy from one way onto another, or from an effort into another effort, or we have this one on the right hand side, which is like called cross transform, because transforms the flow into an effort, or vice versa. These are the elements that we need. So we need to analyze what each one does. And that's what we are going to do next. Before we do that, we are going to add one more thing to our explanation of the notation. If you have an element A and an element B, if power flows from A to B, we're going to symbolize it with this half arrow here. On the other hand, if you have this element in here, B, and power flows from B to A, we're going to have this half arrow indicate that. This power flow is independent of this symbol, because I told you that the symbol, this one and this, depends on which is the output. In this case, if you look at this, which one is the output in here? Huh? Let's see if we can write in here. This one here, see, this is A, this is B. Isn't it true that this is the output right there? And this is the input in here to A. Yeah? So the output and the input in here. Or you could also say this is the cause and effect. So this way we could just say this is the cause, and this is the result, the effect. Or you could have it this way. Seeing here, this is on this side here. And if you have in here, this is the, if we're looking at A in here, this is of course E, and this is the input, and this is F, the output. But I am talking about the A element, because if we talk about, if we as our reference is B, then it would be the reverse. But that's the idea. So in here we're gonna say, okay, we are going to propose this little system in here, and this is the system that I would like to do the simulation of. How is this composed? This is made up of an input in here, which is the SE, and we do let's go right on it. This in here, this is the this is your input in here, yeah, the flow. So we're going to represent that with the symbol. This is called source effort, which, effort is for force. So is the input in here, and the model is see, this is the inertia element in here. We're going to call it, this is your I element. This is your C element, and this is going to be your R element. So if we lay out the elements, we can come up with these connections between them, and this will be a complete model equivalent to a block diagram. The difference being is that the equations are contained within and they can be computer generated. This is connecting it differently produces this produces this junction if you connect it differently. Either 1 for this kind of connection or 0 for this other one. So right now what we need to do is just go and look at the first element, the resistive element. A linear relationship exists between the effort and the flow through this equation. If that's true, you have an R element, like this. You see what I'm trying to tell you? If this is an R element and this is the output of A, it means that